All right, and this last question is a FRQ style question. For this, it says, given a function defined to be this, when x is not 0 and it's continuous for all real numbers x, what's the limit of the function as x approaches 0? So as soon as I realize there's a limit question with a fraction, I'm thinking there's probably going to be some L'Hopital's rule in here. So I don't know why I wrote this all out, because if I plug in 0, cosine of 0 is 1, 1 minus 1 is 0, and then x squared is 0. So I need to go ahead and write separately. Oops, okay, so here's what you don't do. Do not write, so this equals 0 over 0. It just doesn't give you the full credit on the AP exam. If you're applying L'Hopital's rule, I would say, since the limit as x approaches 0 of cosine of 2x minus 1 is equal to 0, and separately, the limit as x approaches 0 of x squared is 0, then I would say L'Hopital's rule, L'Hopital's rule, or L'Hopital's theorem says, I will say the limit as x goes to infinity of cosine 2x minus 1 over x squared is equal to the limit as x goes to 0 of the derivatives. So the derivative of cosine is sine 2x times 2 times a chain over 2x. But then I realized if I plug in 0, sine of 0 is 0, and 2x, or 2 times 0 is 0. So now I have another problem. So I'm going to say L'Hopital's rule again. And since the limit as x goes to 0, of 2 sine 2x is equal to 0, and separately, the limit as x approaches 0 of 2x is equal to 0, L'Hopital's rule, say it again, says the limit as x goes to 0 of 2 sine 2x over 2x is equal to the limit of the derivative of top and bottom, which is going to be what? 4 cosine. Oh, did I do this wrong? Okay, the limit is that, say the derivative of cosine should be negative. So put these all negatives. This would be what? Negative 2x over 2, which is equal to negative 4 over 2, which is equal to negative 2. So L'Hopital's rule twice. All right. Part B, write the first 4 non-zero terms in the general term of the power series that represents the function h of x is equal to cosine of 2x. So I've got to know cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And I'm going to put dot, 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 but I'm not going to put the general term yet. Just because I think it's a bit easier to just find it in a second. Actually, I want to put it. The general term, what would that be? Negative 1 to the nth, x to the 2n over 2n factorial plus dot, dot, dot. Okay, now cosine of 2x, means just plug in 2x for all the x's, right? So it'd be 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial plus dot, 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 negative 1 to the nth times 2x to the 2n factorial over 2n factorial plus dot, dot, dot. So I think we're actually done. We do not need to simplify this. If this is a free response question, those are the first 4 non-zero terms. Don't worry about simplifying it. This is the general term. Do not worry about simplifying it. Just leave it like it is. Now for fun, for the notes, I am going to simplify it. This will be 1 minus 4x squared over 2 factorial which actually needs to be reduced more, plus 4 squared over x to the 4th over 4 factorial, minus 4 cubed x to the 6th over 6 factorial. So I mean, I kind of reduced it, but I kind of didn't. Negative 1 to the nth times 4 to the n, x to the 2n over 2n factorial. But it was fine before. All right, 10 more minutes till class ends. Okay, use the results from part B to write the first 3 non-zero terms of that. All right, so all I need to do here is divide. So I need to take what I had, cosine of 2x, that was equal to 1. I'm going to reduce it now. 1 minus 2x squared plus 2/3 x to the 4th minus 45 x to the, what was it be? X to the 6th. So 4 times 4 times 4 over 6 times 5 times 4 times 3 times 2 times 1. Those 4's cancel. There's a 4 in here, or 2 in there. So I'd have 4 over 9. Where did I get 45? Okay, maybe I should reduce that. Let me just double check this. That was 4 times 4 times 4, x to the 6th over 6 times 5 times 4 times 3. Oh, there's a 5 right there. Okay, so 45. Okay. All right, so then I would do cosine of 2x minus 1. I just subtract 1 from that, and I basically just get negative 2x squared plus 2/3 x to the 4th minus 4/45 x to the 6th. That's why I say in the first 3 non-zero terms. I had 4 non-zero terms in the last one, but as soon as I subtracted 1, that eliminated one of the terms. Now if I divide all these by x, this would give me cosine of 2x minus 1 over x is just equal to negative 2 plus 2/3 x squared minus 4/45 x to the 5th. Oh, it's divided by x squared. Oh no. X squared, x squared, x squared. All right, that's why it's that. Okay. I'm trying to rush. I'm making mistakes. Okay, so that is the answer. The first 3 non-zero terms of what that would be. All right, last question. Use the result from part C. So the result from part C was that cosine of 2x minus 1 over x squared is equal to negative 2 plus 2/3 x squared minus 4/45 x to the 4th plus dot, dot, dot. Now I'm just using the first 3 terms, but this, if I'm saying this is equal, I need to put the dot, dot, dot. Use the result from part C to see if that function has a relative minimum, a relative maximum, or neither when x is 1. In order to have a relative maximum, f prime of 0 has to be 0, and then the derivative either has to change from negative to positive, positive to negative, or the second derivative. You can use a second derivative test to see if it's a relative min or max. So the first part, the derivative, okay, the derivative of this, I could say d over dx. The derivative, or I'm going to say f prime of x is equal to the derivative of this, which is 0, power rule there. So 4/3 x minus 16/45 x to the third power plus dot, dot, dot. Okay, when f prime of x is equal to 0, we just get, we get 0, which is what we want. Okay, the first derivative has to be 0, which it is. Now the second derivative, I'm gonna use the concavity test, would be 4/3 minus 48/45 x squared plus dot, dot, dot. But f double prime of 0 is just 4/3. So what this tells me is that there is a critical value at x equals 0 because the first derivative is 0. And since the concavity is positive, it means it's concave up. Therefore, at that point, it's a relative minimum. So I'm going to say f of x has a relative minimum at x equals 0 because f prime of 0 is 0 and the second derivative of 0 is positive. And that should be good. All right, so if you have any questions, ask me next time I see you in class, and hopefully this video helped. Bye.